that is the characteristics of electromagnetic wave. So to understand this electromagnetic wave, we need to first keep in mind that light is an example of electromagnetic wave. So you know that the propagation of light does not require any medium. That is, in vacuum also propagation of light can occur. So there are certain features of electromagnetic wave that we will mention one by one. First, we have already studied that electromagnetic wave. What does that mean? It has both electric and magnetic field vectors which are present in it. That causes this electromagnetic wave. So oscillating electric and magnetic waves. Due to this oscillating electric and magnetic waves, we can say that electromagnetic wave is produced. Example is light. Okay, light is an electromagnetic wave. Don't think sound is an electromagnetic wave because sound cannot travel in vacuum. So we can say that it does not have oscillating electric and magnetic field. It is not an electromagnetic wave. Sound is a mechanical wave. Okay, so don't get confused. Second is they travel in vacuum, or you can say in space. They can travel in vacuum at the speed of 3 into 10 raised to 8 meter per second. You are very familiar with this value. This is the speed of light. All the electromagnetic waves, not only light, can travel with the speed of 3 into 10 raised to 8 meter per second in free space. That is vacuum. So this is the second point. And third point is they do not need any medium for transmission. They can transmit in vacuum also. So there are certain terms that you should understand in chemistry or in physics when you are studying that lead to the understanding of electromagnetic wave. Certain features. These electromagnetic waves are having wavelength. Wavelength is represented by Greek letter lambda. Okay, lambda, and the speed of that wave is represented by c, or V represents speed. Why we are representing c? The speed is equal to speed of light. That is why c, or we can represent it as v if we are talking about some other waves. We know that all the matter represent, or they are having wave, but they are not EM waves. Okay, EM waves are particularly for electromagnetic radiations. So here wavelength and speed. The frequency is represented by Greek letter nu. This is Greek letter nu. And what is the relation connecting these three terms? We know that speed equal to distance by time. Yeah. So speed equal to distance by time. So I can write it as speed v equal to distance. What is the distance? Distance we can represent it as a wavelength. Lambda divided by time, or I can write lambda into 1 by time. What is this 1 by time? It is a frequency. Frequency indicate reciprocal of the time period. Okay. So V equal to, this is frequency nu and lambda. This is a very famous relation indicating electromagnetic wave, and this is a speed time distance relation connecting electromagnetic wave. The next important term from the electromagnetic wave study, that is amplitude of the wave. What is meant by amplitude of the wave? We already drew the diagram of the simple diagram of electromagnetic wave propagating along the x-axis with electric field vector along the y-axis and magnetic field vector along the z-axis, and this all are mutually perpendicular to each other, and we have represented the wave as like this. Now what is meant by amplitude? Amplitude of a wave, or simply I can draw the wave simply like this also, representing wave. So here what is meant by amplitude? Amplitude is the maximum displacement that it can have. That is this maximum, crust and trough regions. The maximum displacement or the maximum value that a wave can have, that is meant by amplitude. This distance is known as amplitude. So amplitude is represented by capital A. So this is just few terms that you should be familiar when you are studying about waves. Okay. So next term, that is wave number. Wave number. Wave number is denoted by the Greek letter nu with a bar. Nu bar indicate wave number. What is the meaning of wave number? Wave number nu bar is 1 by wavelength. The reciprocal of wavelength is known as wave number. So how many waves are present in a particular area or a particular distance, that's meant by wave number. So its correct definition when we are writing it is the number of waves which pass through a particular point, number of waves which pass through a particular point in 1 second. In 1 second time, how much waves pass through a particular point? That is meant by wave number, and it is equivalent to the reciprocal of the wavelength. So what is the unit of wave number? Reciprocal of wavelength. Wavelength unit is meter. So the reciprocal of meter will be nu bar unit will be meter raised to minus 1, or you can write centimeter raised to minus 1 if you are writing CGS unit. Centimeter gram second unit, if you are writing, you can write it as centimeter raised to minus 1 or centimeter inverse. So what is the dimension of nu bar? Dimension of nu bar will be m0, L raised to minus 1, T0. This is the dimension of which one? Nu bar or wave number. This is all about the different factors that we are studying about EM wave. Okay.